This problem has several parts to it, but all of them amount to basically the exact same thing. We're given a bunch of measurements in degrees, and we want to convert them to radians. So I'm going to go through one example, and the rest all follow the exact same basic process. So let's start with part A, where we're given an angle of 45 degrees. And we can do this conversion, we can convert from degrees to radians, the same way that we would do any other unit conversion. We would use a chain link conversion in which we take advantage of the way that the different units are related to one another. So when we're dealing with angles, for example, the way that radians are defined, 2 pi radians is equal to 360 degrees. Or alternatively, pi radians is equal to 180 degrees. But whatever way you choose to do it, the one at the top has to be equal to the one at the bottom, even if the units are different. And since in this case we're trying to convert from degrees to radians, the unit with the quantity measured in degrees has to be on the bottom in this case, so that the degrees cancels out with the degree in the original value we're given, and is then replaced with the top value in radians. So in this case, for example, if we take 45 degrees and multiply it by 2 pi radians over 360 degrees, then we end up with a value of about 0.785 radians. And this is one way you can express radians, but it's also possible, and very, very common, and in fact, it even asks it in the problem, to write radians as exact values using fractions of pi. And this can be done, most calculators can do with this as well, but most of the time, in order to do it, you have to leave out the decimal point. So like if you were to type this into your calculator, you would just type in 45 times 2 pi over 360 degrees, and you would not add the 0.0 at the end of the 45. I know that sounds like a minor detail, but most calculators do this thing where if there are no decimal points, then it tries to give you exact values. But if any of the numbers do have decimal points, then it then it kind of rounds all of the numbers in the final result. So if you were to use most calculators and just type in 45 times 2 pi over 360, then you'll get pi over 4 radians. And that is an alternate conversion. That is an alternate answer for what 45 degrees are in radians. And so yeah, so there are a few different ways you can do it, but you're using the same general process for every single part here. Just remember this unit conversion, and just remember how degrees and radians relate to one another. So 360 degrees, a full going around in a circle, is equal to 2 pi radians, and half of that, 180 degrees, is pi radians. So now we continue doing that for each part of the problem. For 60 degrees, that's either pi third radians, or alternatively, 1.05 radians. That's part B. For part C, we have 90 degrees, and keep in mind, you probably should be pausing this between every part and trying it for yourself, just to make sure that you're on the same page with the answers I'm given. But for 90 degrees, that turns out to be pi over 2 radians, which can also be written as 1.57. For part D, we have 360 degrees. That is one full going around the circle. That is one full revolution. So that is equal to 2 pi radians, also known as 6.283 radians. So that's part D. And finally, for part E, we have 445 degrees, which is more than a full revolution, actually. But that turns out to be 89 pi over 36 radians, or also alternatively written as 7.77. Let me make this a little clearer. And that's the answer to part E. So that is the answer to all of these parts. If this video helped you out, please consider subscribing, as that'll help me make more videos like this. But if there's anything confusing, you have any questions, please leave a comment down below, and I'll do my best to help you out as best as I can. If you have a request for a future video, or you just want to hang out, I have my Discord server and my Twitch linked in the description below, so check those out if you'd like. But that's all for now, and I hope you have a lovely night. Bye-bye.